Hey guys, my name is Kwame, and this is just going through 1.6.1 and some of the new features that we have. Okay. So on having a clean project, we'll just drag and drop in the Web3 Unity package and import. Okay, and if it's the first time that you've used the project, you'll most likely see, this pop up. You can see here that it's already configured with some default settings. But if it's the first time, you'll need to click on Need to Register. This will bring up the registration area. Mine logs in because I've already been logged in, but you'll just need to sign and then create a new account and then update your project with the project ID. And you can set in the defaults for chain ID, chain network, and the default RPC, and this will be stored locally inside of your game, and it will reference that, but you can easily override it also. Okay, so now that we have that, just the basic setup as always. So for us, we'll go Build Settings. We're going to do Web, so we're going to switch to WebGL. We'll go to our Player Settings, and inside the Resolution and Presentation, we want to make sure that we select WebGL. And for our other settings, we will just uncheck the auto and let Unity figure out what's the best for us. Okay, so let's set up the order of which we want the gaming SDK to run. So the typical workflow is that you will select the scenes, and for this we're going to use a WebGL login this time. And last week we were doing wallet logins, but we're going to be doing WebGL logins, and then the scene, and we'll just drag in our sample scene. Okay, so that's good for setup, and make sure that we have switched our platform over to WebGL. Okay, great. It's doing some of the recompiling process. We'll just let it do that. Okay. Now, also, inside of our WebGL templates, you'll notice here that we have one for Chronos and one for WebGL. And inside this network folder, if I just open this up, you'll see here that we have these default chains. Okay, so this one here, number 5, is going to be for Gorley. And if you're adding in a different RPC, just take the RPC value for the chain ID and then just pass it in here if you're working with a different one. Since the default is Gorley, and for most of the tests that I do is Gorley, it's just left at 5. But this is something to note if you are using a different chain that has like a different chain ID, to just update that here. Okay. So what we'll do is that we will just, create a sample, a C# script. This is kind of like the hello world of the ChainSafe Gaming SDK. And we'll just call it account. And then I'm going to open this up. New window. Now with this script being up, I know that we're going to need a using engine.ui. I'm going to need a public text property for the player account. And then the player account has a text property. And then we're going to assign it the player prefs. Get string. And this is under account. So when we log in, we are going to get an instance of the public player's address, and then we store that in player prefs, and then we can just use that as a reference anywhere in our code that we need it. So I'll save that. Go back into Unity. Okay, so now that we're back in Unity, let's just right click and we'll create a UI element. I'm going to use a legacy one here and just like, like a text property. I'll just call this account. And then I will zoom into that. I'm also going to change my layout. And then I'll just hit F. And just update these positions here. And then I will just kind of make it more viewable. I'll change this to account. And then I will just center this text. To span it out, since we'll be displaying the account. Okay, so now that we have the account selected, let's attach a component, and we want to attach the account script. The account script has a public property for that text field that we just created, so we'll just drag and drop and assign that. Whoa, there we go. And now we can save that scene, and we will create our WebGL build. Okay, so now we have our project up, and we can click on Login. Enter your password if you need to. Select an account you want to work with. And now we have successfully connected Web3 Unity to our WebGL project. Now let's continue on with the actual game. Okay, so the style of game that we're going to make is an endless runner type game. So the first thing that we're going to need to do is kind of like just create like the player and like the game world that we're going to set up with. So the first thing that we're going to need to do here is to create a 3D object, and I'll just right click 3D object, and we'll create a cube, and we'll give this name of floor, just name it floor. And what we also want to do is kind of like zero out the position. You'll see that it's kind of out there right now, and you can see it now inside of our game area. And we're going to basically scale this out. So we'll do 7 in X. On Y, we'll make it 0.1, and on the Z axis, we'll give it 10. So we kind of have like a little area for our player to basically be placed. The next thing we're going to need to do here is add a box collider. So we'll just say box collider, and now, you know, when an object actually hits the box, it's not going to go through. And the next thing we're going to do is that we're going to basically create a player. So we'll right click again, and we'll select 3D object, and this one is going to be a sphere. We'll give it the name player, and then we are going to set its position to 0, set it to 1 on Y, and then we'll set it to -4. So now you can actually see that this is inside of the game view, and it's just slightly above the ground floor. Okay. So the next thing that we need to do here, of course, is basically test this out. So we'll click on play. And I forgot to add a rigid body. So let's select our player. We'll select on add component, and I'm going to say a rigid body. Now this rigid body will apply gravity to it. So you'll see here that on the rigid body, we have this selection here that says to use gravity. So now when we click, we'll see that this sphere will actually hit the ground. So let's click on play again. And great. So everything seems to be working there. So let's continue on. So the next thing that we're going to do here is create a C# script, and this will allow us to control the player. Okay. So let's go back into our scenes. We're going to create a folder, and just give it the default of scripts. And just to make our stuff more organized, we can just move our account into the scripts folder, and we'll let Unity compile. And now we will create a new C# script, and I'm just going to call this player behavior. This will control the player's behavior in the game. And then we will open that up. Okay. So the first thing that we're going to need here is to, let's add a comment. We'll have a reference to the rigid body. And we'll just say private rigid body, and this RB for rigid body. We'll have a value for the dodge speed of our character. So we'll say how fast the player moves left to right. This will be a public float, and we'll just say dodge speed, and we'll give it the initial value of 5. And then how fast the player moves forward. So this will be like an initial value that we give to the player to project it forward. Let's say 5 for that. Okay, so on start, we want to get access to the rigid body object. So we'll say get access to rigid body. And then we'll say RB is equal to get component, and the component that we want is the rigid body, and that takes care of that. Now on the update, we want the player to initially start. So we'll say check if we are moving to the side. So we'll say bar horizontal speed, and we'll access the input system, get access, and we'll say horizontal, and this is going to be times the dodge speed. And then we'll have the RB add force, and where this is going to be the horizontal speed that we defined earlier. We don't want any movement on Y, and then the roll speed on the Z-axis. So this was going to propel us forward. Okay, great. Okay, so now that we have that, what we need to do here is to attach this player behavior to our player. So we'll just scroll down, we will add this component, and we'll call this the player behavior. Okay, so you'll see that we have these initial values for dodge speed and roll speed. And now if we click on play, and move left to right, you can see now that we have a moving character that's actually controlled by our input. Okay, so if you're still following along and you see that, then that's great. Okay, so let's return back to our script here, and it's going to go back in here, and we have this update. Now this update is going to be continually, going based on the speed of the actual computer. So what we want to do here is that we want to add a fixed update, and this is going to be a lot more smoother. So if someone has a really fast computer or has a slower computer, the gameplay in the update is going to be relatively the same. So now if we save this and we go back into our game to test this out, and I'll just click on stop here, falling into the ether. We will click on play, and then you'll see here that it's a lot smoother. It's not so like get up and go. Now if you do want that kind of that flow to your game, then you'll just have to update the actual roll speed and dodge speed on start. Okay, so far so good. Now let's click on stop here, and we'll go back to editing our script and updating our player. So at this point, what a really good thing to do is let's add a camera onto our player, and so that it actually follows it as we're playing. So I'm going to right click, and I'm going to create another script, and I'm going to call this the camera behavior. Okay, and the one thing that we're going to need to do is have a transform, and the transform is going to be the target, so what the camera is actually going to follow. We're going to create a vector 3, and this is going to be for the offset, and this will just be a new vector 3, and it'll be 0, 3, and -6. And you'll kind of get an idea of what this offset is based on the initial values that we set for the position of our player. So you'll notice here that ours is just going to be a bit behind where the actual character is, and we set the initial value on Y to be 1. So this is 2 units higher and further back. So it will be pointing to the back of the character. Now, we don't need anything on start, but we do need to edit our update. So what we want, the logic that we want to have here is, let's put a little comment and say, check if the target is valid, right? We want to make sure that this is a valid object before we start trying to track or target or anything. So we'll say if the target is not null, then let's do the following. Okay, so now that we have that, we'll set the transform position equal to the target position, and we'll add that offset to it. Okay, so that solves the first problem. And then what we want to do next is change the rotation to face the actual target. And we'll say transform dot look at, and this is going to be the target. Okay, and that is pretty much it. There is not much going on there. So we'll save this, and the next thing after Unity kind of compiles and does what it needs to do here, we're going to select the main camera, and then we're going to add a component, and then we'll just call this the camera's behavior. Okay, and now that that has that, you'll notice here that we have this target for the transform, and the target transform is going to be the player, so we'll just drag the player into that target area. Okay, and now that we have that, we can click on play. And you'll notice right off the bat that our camera is now locked onto the player and it's following it. So if you have that, again, really awesome. And let's continue on. So now that we have our script attached to our player, it's following it. We have the the game world, all that is going great. Now let's basically edit this floor area to have the actual endless runner working. So I'm going to select the floor, and I'm just going to duplicate it. And for the first one, I'm going to call this left wall. Okay, and we will go to our values here, and we will set the scale on this to 1 and 2 and 10 is fine the way it is. And for the position, I'm just going to add in 3 here, 1.05, and 0 is good. Okay, that is great. And now we're going to duplicate this. And then we'll call this the right wall. And then for this one, we're just going to do -3. And that's basically it. Okay, so we have this wall basically set up, and now we can kind of do a little bit more, cleaning up on it. So now what we want to do here is that we're going to create an empty game object. So I'll just right click here. I'm going to create an empty object, and I'm going to call this tile end. Okay, so we have our tile end here. And on our tile end, we are going to add a box collider. So I'll just add component and a box collider. Okay, great. And for the actual scale of the box collider, I'm going to say 7, 2, and 1. And for the positioning of this, we're going to set this to 0, 1, and 10. Okay, great. And now we can just, hit F to focus on it, and you'll see here that we have, this box that is off just a bit above where our current tile is. Okay. Now, the one thing that we're going to need to do is select is trigger, because we're going to trigger an event, once we're interacting with this piece. So just make sure that you have that, and we're good to continue on. Okay, so let's go and create another game object, and it's going to be an empty game object. So we'll right click, create empty game object, and we're going to call this basic tile. Right? With this basic tile, we want to make sure that we set its position to 0, 0, and 0. Okay, and that is great. And now we want to take the floor, the tile end, and the left and right wall, and then we will make it a child of our basic tile. Okay, so here we go. We're going to select our floor, our left wall, right wall, and tile end, and we will move this over into our basic tile. Okay, perfect. Now, currently our camera starts where the tiles are, so we basically need to fix that. So on the basic tile itself, the position, we can just leave it 0, 0, but on the z-axis we want to have a -5. All right, so now here we go. Okay, so things are looking good. So the next thing that we're going to do is we are going to create a new object that's basically a child of our basic tile, right? So let's right click in here, and then we're going to create an empty game object. and we are going to name this next spawn point. Okay, and we have 0, 0, and on the z-axis we are going to set it to 5, right? And you'll see here that there's like that little pop that basically came up. And if we like select it here, you'll see that if we kind of like move in, that there's this like point. So once we are creating our tiles, this will be the point where the next tile will be generated. Okay, so inside of our scenes, let's right click and we're going to create a folder, and we're going to call this prefabs. Now, if you're new to Unity, a prefab is just a prefigured set of components that that either could be like an object, a level, a player, or something that you just want to basically reuse, and you can create a prefab that has that functionality already contained in it. So what we want to do here is we want to take, we'll open up the folder for the prefabs, and then we'll take this basic tile and we will just drag and drop it in there. And now you'll notice that we have this like little pre-configured object, and you'll know that the prefab has been created if you see this blue basic tile. Okay, so in this next section, we're going to start by making our game like an endless running type of game. Okay, so what we're first going to do is that we're going to start off by just deleting the basic tile, because now we have a prefab, so we can programmatically create this. And inside of our scripts folder, what we're going to do here is that we're going to create a new script. We'll right click, create, and it's a C# script, and we'll just call this a game controller. Okay, so now we have a game controller, and we will double click and open that up. Now, the first thing that we're going to need to do here is we're going to have a public transform. This is for the tile. We're going to have a public vector 3. This is going to be the start point. This is going to be a new vector 3. We're going to have 0, 0, and -5. Okay, and you'll notice that we had this similar positions before. We're going to have a public int for, and this variable is going to be init spawn number. So how many tiles are we going to spawn on the starting of this game? We'll have a private vector 3, and this is going to be the next tile's location. And we're going to be doing some like how the next tile should be rotated. It's not really rotated in this sense, but we need something to be able to handle that. And we'll use a quaternion here. And quaternions are used to represent rotations. And Unity gives us a very easy way to interact with that. And what are we going to do now? So we have the initial plumbing to kind of get this thing going, but we want to basically set our starting point. So I'll put a little comment, set up starting point. Okay, and we'll say next tile's location is going to be equal to the start point. The next tile rotation is going to be equal to the quaternion identity. Okay. And then we are going to basically loop through, and we'll say for int I is equal to 0. If I is less than the init spawn number, we will just increment this by I. Okay, so basically what we want to do is that we want to call a function that's spawn next tile. And then we'll just create a method for that, and then we'll go on and implement it. So what is spawn next tile going to do? So we'll create a variable called new tile, and we will instantiate tile, next tile's location, and the next tile's rotation. Okay, now we need to figure out where and at what rotation we should spawn. And we'll say var the next tile is equal to new tile find, and this is the next spawn point. And the next tile's location is equal to the next tile's position, and the next tile rotation is equal to next tile dot rotation. Okay. And then we can save that. Okay, so now that we have that, let's go back into our game, and we are going to right-click. We'll create an empty game object, and we're going to call this game controller. And we will add a component, and this is going to be the game controller script that we created. So we'll just select that. And now you're going to see here that we have this tile, right? Or the tile, like what is that? So what we're going to do here is that we're going to go in and drag our basic tile in there. And if everything worked out, we should see a bunch of basic tiles being created for us. So let's click on play. Okay, great. So now we have our endless runner working. And by the time we get to the end here, we will just basically fall off. So we finished off the last example, and you can probably maybe envision a little problem that we may have here. Well, if we have an endless runner and we are adding in 10 basic tiles, and we want to, add in, more tiles, well, isn't that going to be a lot of tiles? And yeah, you guessed it, it is. So how can we basically circumvent that? Well, after a certain point in time, as your character is basically moving through the game world, it would be a good idea to have, all these tiles that are no longer inside of the game scene to be, disposed of. So this will basically save on memory and will not bog down the game. So let's write a new script that will handle that for us. So we'll go into our scripts, we'll right click, we will create a C# script, and we're going to call this tile end behavior. And we will double click on that. Okay, so the first value that we're going to have here, it would be a public float, and this is going to be our destroy time, and we'll just set this to 1.5f. And what we're going to have here, that we're going to have a private void and on trigger event, on trigger enter. And what we will do is that I like to just call this collider because it just kind of makes sense. So the first thing we'll do here is we'll check if we collided with the player. Okay, so we'll say if the colliders game object dot get component our player behavior, then we'll say if we did spawn a new tile, so game object dot find object of type game controller and got a little bit ahead of myself here. All right, that looks better. And what do we want to do? We want to spawn next tile. And then after that, we want to basically destroy the game object. So, and destroy game object. We'll just say destroy, say transform dot parent dot game object and the destroy time. Okay, so far so good. Okay, so we have an error here, so let's look at why. Tile end behavior. And we'll go into our game controller and oops. Okay, so it should have been public and we made it private, so that was the reason for that. So let's kind of clean up our stuff here. Okay, we can kind of continue on. So what we want to do is we want to add our script to the prefab that we have. So let's let Unity do its thing, and we'll select the prefabs folder, and then we will just open up our basic tile. So we are going to select the tile end here. And then what we want to do is add that tile end behavior component to this. So we'll just select this and say tile end behavior, and then we have selected that. Okay, so let's get back into our game scene here, and we are just going to click on play. Okay, and we have our tiles here, and you can see now how it's actually, deleting one from the back and then adding it to the front. And so now we have that endless runner, but we notice here that we don't have, tons of, objects there. We're just using exactly the amount that we need, and then we're like recycling. And there's a concept for this. It's called object pooling, and we'll get into this later. But this is kind of the general synopsis of having this endless runner game, and it's working great. Okay, so, this game wouldn't be fun unless we had, some obstacles, to, kind of get in the way and to, basically add to the gameplay. So, what we're going to do here is that we're going to create a new object, and this is going to be a cube, and we're going to name it obstacle. We're going to change the white scale to 2. Oops. Its scale to 2. And then let's update the position. So the position on the x-axis is going to be 0. On y is going to be 1. And on Z is going to be 0.25. Okay, great. Now let's build our game. Okay, exactly what we expected. We have an obstacle in our way, and we can, move out of the way and continue on with our game. So the next thing that we're going to do here is that we're going to actually create a new script, and we'll just right click and C# script, and let's name this an obstacle behavior. And then we can double click on that. In the using statement, we're going to add something new here. This is still from the Unity engine, but this is going to be for our scene management. So, on colliding with the game, the player should, quote unquote, die. And what do we want to do with the scenes? So we could, load a new scene. We could say it's an endgame screen. We could, do many different things with this technique. So we're going to create a public float, and this is going to be the wait time, or the time from once we've collided to we do something else. So we'll say 2.05f, and we're going to access the private void and on collision enter, and I'll just leave it with collision, that's fine. That makes more sense. And what do we want to do here? So let's put a comment. We'll say first, check if we collided. It's pretty important. Okay. So we'll say that if the collision dot game object dot get component is the player, what do we want to do? Well, we want to destroy the player. So we'll say destroy, and then collision dot game object. Okay, makes sense. And then the next thing that we're going to do is call the function to reset the game. Function to reset game. So we're going to invoke reset game based on the wait time. Okay. So now we need to actually create this function. So we'll just put a little comment here and we'll reset game. And we'll say private void reset game restarts the current level, and we'll say scene manager load scene manager get active scene and the name. Okay. So far so good. So now we'll go back and we will let Unity do its thing. We will select the obstacle, and then we will scroll down, click on Add Component, and we'll call this the obstacles behavior. Okay, and now basically the main test that we need to do for this is to, click on play and then make sure that the resetting of the game starts. So we hit it, and there we go. Okay, so now that we have some working functionality, let's take this obstacle and we are going to make a prefab out of it. And we'll just drag it into our prefabs. We'll see that it's gone blue, and then we can just delete this now. It's no longer needed. Okay. So now that we have that, we have our prefab for our obstacle that we're going to use inside of the game world. The next thing that we want to do is create some basic, indicators, spawn points, right? So this is going to allow us to, pick and choose like what parts of the, the game world that these particular obstacles are going to be displayed. So the next thing that we're going to do here is that we're going to expand the basic tile. So let's go into we'll basically drag it into the game world here, because we need kind of like a reference of where, these specific things are going to go. So now that we have that, so now it's expanded. Okay, great. So we are going to go to the next spawn point here. And we're going to move its position to Okay, so let's duplicate this, sorry. And let's name this center. And then we will set its position to 0 on X, 1 on Y, and 4 on Z. Okay, and that's good. And a good thing to basically do here is to give it some color. So we can select this here and then just give it a color, and then that way inside of the game world we can see here that it has this like little moniker, because sometimes when you're working with these objects that don't actually have like a 3D object associated with it, it can kind of get lost when you have like a lot of different things. So this is kind of like a good tip for you guys to to incorporate into your games. Let's add a new tag and click plus, and we're going to call this the obstacle spawn. Obstacle spawn. And we'll save this new tag. And then let's select this and then select the actual obstacle spawn tag on it. There we go. So we're going to duplicate these guys again. So we'll say duplicate, duplicate, and these are going to be for the left and the right. And then we can just basically move these a couple units out. So for the right, let's just move this here. And for the left, let's just move this guy over here. In the center, let's just move this guy here. And we kind of want to keep it a couple units, but we can eyeball it for now, and then think about how we can make this better after our initial testing. So now that we have that, let's go into our scripts. We're going to get back into the game controller, and now we're going to create another transform. So public transform, and this is for the obstacle. And then we will create our, let's move this, kind of keep all the transforms with the transforms. Okay, now we want to have a variable for the initial number of obstacles, and we'll set that to 4. And then in our spawn next tile, we want to have a bool for spawn our obstacles, and then we'll set this to true, and then we'll add some logic here to say that if the spawn obstacles is true, then we want to spawn obstacles, and we want to pass a new tile to it. There we go. And then we will create a method for that. Okay, perfect. So since this is going to be a list of objects, we need to add in the generic, and it's here already for us, so that's great. So now we can just basically go through and implement this spawn obstacle. So you should probably add obstacle. And okay, now we can go ahead and implement this. So we'll create a variable for the obstacle spawn point. And we'll say a new list of game object. And now we want to go through each of the child game objects in our tile. Okay, so now we'll say for each transform child in new tile, we can have our obstacle spawn points dot add the child game object. Okay, and this here, and this kind of got caught in the ethos here. Okay. Now, if if the child compare tag is obstacle spawn, and do the following. I'm going to take this guy and add it in here. Clean up some of this stuff here. Okay. Now make sure there is at least one. So if the obstacle spawn points count is greater than 0, what are we going to do now? So we're going to have our variable for our spawn position, and this is equal to, actually this is our spawn point, and it's equal to the obstacle spawn points, and then we'll say random range from 0 to the obstacle spawn points dot count. We want to store its position. So variable spawn position is equal to the spawn point transform dot position. Then we want to create an obstacle. Var new obstacle, and instantiate the obstacle spawn position and the quaternion identity. And then we'll have it parented to the tile. And new obstacle dot set parent spawn point dot transform. Okay, so now we can update the start. And I think start might have gotten removed, or is it up here somewhere? Okay, no. So let's update our start. And we have our starting point, and that is good. But here, in the spawn next tile, what we want to do is have I is greater than or equal to the init, the number of obstacles. Okay, so now we should actually be able to save this and then go into our game again. Okay, so let's try this again. Okay, there we go. So now we have our obstacles, and we have some, additional gameplay. And just to make sure that everything works correctly, let's collide with one of these tiles. Oh, okay, so we found our first bug in our game. So let's unselect that. Let's go back into our obstacle. Just make sure we have our box collider. That should be good. There we go. Okay, and now it's back to normal. Be a little bit faster on the beginning, but so far so good.